Let us start asking ourselves a question. What comes to our mind when we hear this term fiber optics? What is optical fiber? Where do you see it? Do we see it in our daily lives? Can we recollect some things where we see optical fiber? I have a few things to show to you. Let us see. You might have seen something like this, in which if I put light, then you can see it glowing everywhere. I have used a multicolor LED to illuminate it, and you can see that different pieces of fibers are glowing and the colors are changing. This is a kind of fiber which people use for decorative purposes. I also see a fiber something like this, okay, in which if I put light inside, I can see light coming out of the other end. This looks like a normal wire, but it guides light. You can see what a flexible structure it is, and it can take light around all the curves over a long distance, over the entire length of this piece of wire. So this is another form of optical fiber. We also see fibers something like this. This is really hair thin. This is really hair thin structure, and I can very carefully couple light into it, and light can come out of the other end. It can guide light over kilometers length. We also see something like this. This is a fiber which is jacketed. It is a similar fiber which I showed you earlier. It is jacketed. You can notice the color. Its color is yellow. The color of the jacket is yellow, and it signifies it is single mode fiber. Well, what is a single mode fiber? We will learn as we go along. This is another similar kind of fiber, but it has an orange color jacket. It is known as multimode fiber. Again, this term multimode we will understand as we will go along. You may have also seen something like this. This is a very flexible cable, but it takes light along it. So if I put light into one end, you can see light coming out. So if I take light from here, it can be illuminated. So I have different types of fibers. You also think, where do you see fiber? What comes to your mind when you hear this term fiber optics or optical fiber? Let us look at where do we see fiber in our lives, and how does the fiber look like. Let us first have how the fiber looks like. What exactly is optical fiber? So it is having a very thin core in the center, which is made of certain material. Here I have shown it is made up of doped glass, and it is surrounded by another material which is called cladding. This material can be for example pure glass, and this region is called cladding, and this forms a flexible structure which can carry light over very long distance, and the material can be glass or plastic. This is typical glass fiber illuminated by green laser light, and this is typical plastic fiber bundle which is illuminated by white light. Where do we see fibers in our daily lives? Well, the very first use of optical fiber was in endoscopy. The bundle that I showed you here, this is the kind of bundle of fiber which is used in endoscopy. What does it do? Well, you can slip in this kind of fiber inside the human body and image it inside. You can see the ailments which are happening inside, and if you put a laser beam through it, you can even do surgery. This is minimum invasive surgery. What you have to do, only puncture some small holes in the human body, slip in the fiber, put the laser light, image it, do the surgery and treat the ailments. This kind of surgery is known as laparoscopy. Where else do we see fibers? Fiber can be seen in flyovers, installed in flyovers to sense any strain or stress developing in the structure. So you can use fiber sensors to monitor the health of civil engineering structures. You can do 24/7 real time monitoring. Any defect can be detected at the initial stage itself and the precautionary measures can be taken. So it can be used to monitor the health of the flyovers, railway bridges and building, and you can do real time monitoring of the health of these structures. This is one example of Taiwan's first ever all round full bridge fiber optic monitoring system. It is capable of performing 24-hour all round bridge monitoring. If there is any abnormality detected, then the bridge management unit is immediately notified by means of computer or smartphone, and precautionary measures are taken. This system can also be combined with traffic signals to immediately prohibit use of vehicles or pedestrians. Another application that I see is in illuminating the places like museums, caves, or where you have very precious artworks. Why do we need this? Well, in these kind of places we have artworks which are very sensitive to thermal radiation, and if we illuminate them using ordinary lamp, then these lamps do not only give light but also heat the artworks. So these kind of lamps degrade the quality of artworks. So to prohibit that, to address this issue, what can be done? You can put the lamp outside. For example, in this Ajanta caves, you put the lamp outside, take the light using optical fiber bundle through this, the fiber is running along this, and then take this fiber bundle inside the cave and illuminate it. You can see the blazing light coming out of fiber bundles and the whole structure is illuminated. In this way, you can only transport light through optical fibers but not the heat. So your artworks are protected. We can also use optical fibers for improving our ambience. For example, you can make a ceiling of hotel lobby like this, or you can make the ceiling of your car like this. You can also use optical fiber for your personal use, like you can make a fabric using optical fiber. You can basically weave in the optical fiber which is side emitting and then illuminate it using different colors. So you have color changing fabric. You can dine on light if you use this kind of fabric. But of course, the very important use and the most important use of optical fiber is in telecommunication. It is really wonderful to see from where we started and where we have come. What a tremendous advancement of technology has happened. We started with telephones something like this, and now we have a smartphone, very small phone which has all the capabilities. You can do whatever you want. We started with internet, it is something like first generation internet in 1981. Using that we could just browse few websites, use internet email perhaps, and now we are heading to 5G, maybe in 2020 or before. In initial days we had computers which looked like this, and now we have computers which are handheld. On your palm top you can do everything. We used to watch television on very big CRT screens. Now television can be mounted on wall. We can even watch videos over on our mobile phones, over on our tablet computers. We can watch television over internet, and all this could happen because of tremendous advancement in technology in the area of photonics and particularly in the area of fiber optics. Today we are connected globally. The world has become really very small. We are connected to our friends, to our families, wherever they are, using various social networking sites, emails, internet, etc. And the credit goes to fiber optics. You will wonder that I am saying that you are talking on mobile phone, then where the fiber optics come into picture. You are browsing internet, where I am using optical fiber. I am sending message using WhatsApp, where I am using optical fiber. Well, what we see basically is this domain. We use our mobile phones which communicate to this local cell tower. You might have seen these kind of cell towers in your localities. Now if I want to send a message to a mobile which is in New York, how does this data go? Well, this local cell tower is connected to another tower which is connected to optical fiber and carrier core network, but the connection between these two towers is using microwave link. The connection between your mobile phone and this tower is also through microwave link. This microwave link has a limited data transmission capacity, which is about 100 megabits per second. So you send data from this tower to this tower at 100 Mbps over a few kilometers, and then fiber takes over. This data goes into optical fiber to, for example, Delhi. This fiber is buried under the ground, and then from Delhi to Mumbai, and then from Mumbai to New York using optical fiber. You will say how? You will say how from Mumbai to New York using optical fiber? Well, there are submarine fiber optic cables. Cables are buried on seabed, something like this. This is a submarine cable map. It shows that millions of kilometers of optical fiber is buried on seabed, is lying on seabed, connecting the whole world. Okay. Here you are in India, and then you can go to Europe and to the US. Okay. So it is this fiber which takes your data from Mumbai to New York. It is this fiber which downloads data from Europe to your computer in Roorkee. Well, now there are some historical facts. This very term fiber optics was coined by Narendra Singh Kapani. He was born in Moga, Punjab and educated in England, and his was the first PhD thesis on fiber optics in the year 1955 from University of London. The fibers on which Professor Kapani worked could be used to transmit image only over a meter or so. The fiber was very lossy. He used a bundle of optical fibers which could transmit image over a meter. But at that time people were not able to transmit light over long distances, not even up to 10 meters, forget about kilometers, because the fiber was very lossy. And remember, I am talking about mid 50s or late 50s. At that time laser was not available. So it was not possible to use optical fiber for telecommunication. Then what happened? A revolution happened. The laser was born. In May 1960, Theodore Myman demonstrated the first laser. It was a ruby laser. He demonstrated it in Malibu. And few months later, L.I. Javan demonstrated first helium neon laser at Bell Labs. And this marked the revolution in the area of photonics, in the way we live, in the way we communicate to each other, in several other things, because this laser was very spatial source of light. It was very powerful, directional, coherent, monochromatic, all these things in one single source. It was a miracle. And using this kind of source, people started playing with it, trying to do whatever came to their minds. And they also tried to use these lasers for telecommunication because they were very directional. So they thought that they can use these lasers by open air or open atmosphere communication. But of course there were limitations, because if you are using a laser through open atmosphere, you are doing communication. For example, you are transmitting some music signal, you are listening to music, and suddenly a bird crosses the laser beam and your music stops. Suddenly fog settles in and your beam is attenuated. If there is thunderstorm, there are dust particles, they scatter light, beam is attenuated. So in the years 62 to 63, experiments showed high loss when sending laser beams through open atmosphere, and fibers already showed too high loss to be used for telecommunication. So during this time in early 60s, people had lost interest in using optical fiber for telecommunication. They thought that it can never be used for communication. At that time America was leading the world in developing lasers and optical fibers, but for different applications. America virtually ignored the idea of fiber optic communication. So it was put in a cold bag. But at that time a young Chinese engineer, Charles Kao, he was still pursuing this idea of communication using optical fibers, and at that time, let me tell you, the loss of optical fiber was 1000 dB per kilometer. It means that if you send light through 20 meters of optical fiber, then only 1% light remains, which means that if you put 100 milliwatt of light at one end of 20 meter long fiber, at the output end you will be left with only 1 milliwatt, but 100 milliwatt is huge, you do not use 100 milliwatts. So, only 1% light remains after 20 meter. This was the kind of loss in optical fiber at that time. Charles Cow and George Hockham, they very carefully studied everything what was available at that time, the lasers and their power available at that time, the detectors and the sensitivity of detectors, what is the weakest level of light intensity or light power the detectors could detect, and the fiber itself, how fiber is made, what are the sources of losses in optical fiber. All these things they studied in very detailed manner and made a daring conclusion in a historic paper. And just look at this conclusion which they made, the proposition which they made in 1966, and it was a fiber with 20 dB per kilometer loss can realize the dream of optical communication. 20 dB per kilometer loss, what does it mean? It means that you are bringing down the loss factor from 10 to the power 100 to 10 to the power 2. I hope it is not a joke. Bringing down the loss factor from 10 to the power 100 to 10 to the power 2, but their study was very extensive and some people took it very seriously. And then there was another revolution. In 1970, Corning Glasswork produced a fiber with 16 dB per kilometer loss at 633 nanometer wavelength. And within a decade the fiber loss could be brought down to about 1 dB per kilometer, and it was just the beginning. Today we have fibers with loss less than 0.2 dB per kilometer, which is approximately the theoretical limit. So, whatever today we have is because of Charles Cow. Because of his daring proposition, the optical communication, fiber optic telecommunication could take off, and today all these social networking sites, internet, television, all these things which we are enjoying is because of this. So, for his tremendous contribution in the area of optical fiber communication, Professor Cow is widely regarded as father of optical fiber communication and has been awarded 2009 Nobel Prize in Physics. Now, let us look at fiber optic communication system and what we are going to do in this course. This is a typical block diagram of optical fiber telecommunication system, where we have electric signal. So, whatever data we want to send, it is converted into electric signal, whether it is voice data or image or a video. So, we have electric pulses. These electric pulses drive light source and produce optical pulses. These optical pulses are sent through transmission medium and they are received at the output end by optical detector, where they are converted into electric signal again. So, we have three primary components here: light source, transmission medium and optical detector. and we are going to study about this. We are going to study individually the light source, transmission medium and optical detector, and then the system as a whole. The transmission medium is optical fiber. So, we are going to study what are the transmission characteristics of optical fiber, what are the light sources which are used in telecommunication. So, we are going to study about light emitting diode and laser diodes. Then how the optical pulses are detected at the output end. So, we are going to study about photodiode, PIN detector and avalanche photodiode APD. Apart from these, we will also study various components which are required in telecommunication system, for example power splitter, polarizer, multiplexer, demultiplexer, okay, all these components which are made up of fiber itself. So, this is the course content. We will start with need for optical communication, why at all we need optics or optical waves for communication. Then what are the salient features of optical fibers, what is the structure, how the light is guided, then how an optical fiber is fabricated, what are the materials used, what are the techniques for fabrication of optical fiber, what are the transmission characteristics when these optical pulses go through optical fiber, what happen to them and what causes the distortion of optical pulses. And to understand the transmission characteristics of optical fiber, first of all we should understand how light propagates in a room like this. So, how light propagates in an infinitely extended medium. Then we will study the light guidance mechanism in a very simple optical waveguide, which is a slab waveguide, which is something like this. If you have thin slab, this is very thick, if you have a thin slab of glass for example and you silver it here and here, then you send light, then because you have silvered it on the top and the bottom, then light will bounce back and forth and will be confined in this structure. So, this is a very simple planar mirror waveguide. So, how light goes through this, and then we will move to planar dielectric waveguide. If we do not put any metal coating or silver the top and bottom of this kind of a structure, then also it can guide light. This is planar dielectric waveguide. So, how does this guide light, and then we will understand how optical fiber propagates light through it in a cylindrical geometry. We will talk about single mode fiber, properties of single mode fiber, which is primarily used in long distance telecommunication. Then since this fiber is used over hundreds, thousands of kilometers, so it is natural that we will have to join two fibers together at some point. When we join two fibers together, then what happens at the joint? What are the kind of losses at the joint? They are called splice loss. So, we will study about them. Then waveguide dispersion, which is one of the mechanism responsible for broadening of pulses. Then optical fiber components and devices, which include power splitter, multiplexer, demultiplexer. Then how do we manage the attenuation of pulses in an optical fiber? Then how do we manage broadening of pulses in an optical fiber, that is dispersion management. Then sources for optical communications, what are the properties of light emitting diodes, what are the properties of laser diodes, then detectors for optical communication, how light is detected in a photodiode, what are their basic characteristics, what are their efficiencies, and then after doing all this, then we will be able to do system design, the design of the system as a whole. What are dispersion limited system, attenuation limited system, power budgeting of the link, all these things we can do. Then we will also learn few techniques of measurements of different properties and parameters of optical fiber, and lastly what are the recent advances in fiber optics. This would include weekly assignments in the form of multiple choice questions. The suggested textbooks are Ghatak and Tyagarajan, Introduction to Fiber Optics, and Saleh and Teich, Fundamentals of Photonics. In addition to these two textbooks, there are 4 books recommended for additional reading. These are G.P. Agrawal, Optical Fiber Communication System, G. Kaiser, Optical Fiber Communications, Snyder and Love, Optical Waveguide Theory, and Senior Optical Fiber Communication. At some places in this course, I have used or adapted images from various sources such as internet websites, Wikipedia, and several books, including the textbooks and additional reading mentioned in the previous slide. I have tried my best to make proper attributions wherever I use such contents. If I have missed to acknowledge the source of information, it is purely unintentional, and I would be very happy to correct it in subsequent version. Thank you.